but it's certainly a very good to be here, and also to see that there's so many experts actually on the. I was going to the meetup and seeing that there's a vibrant community, over 1,000 folks in there, and just glad to see that there's quite a few people joining as well. So without further ado, I am just going to maybe introduce myself. As Harpreet has mentioned, I'm from Oracle Labs, and my role is basically as part of the Oracle Labs in the product management space, looking after GraalVM and also Micronaut. Functions and serverless is a part of the Oracle ecosystem, and so recently we've done some projects where we've combined the expertise and the tooling across these three different types of products, especially looking at it from a framework like Micronaut and how GraalVM comes in, and also for functions and where it is able to make it say for example prevent things like cold starts and so forth. So that's a pretty interesting time. Today, in terms of the agenda, so what I'm going to do basically is keep it interactive in the sense that if you guys have any questions, feel free to stop me and ask. As per your format, I'm really flexible. But one of the things I'm going to be explaining is essentially the three different technologies, just as a high-level introduction, how they work together, and more importantly, from the energy efficiency, what kind of tests we have done on a before and after, and showing that we've got some energy savings and CPU memory savings for your server workloads and things like that. So when we typically see the traditional frameworks overlaid on the modern architectures, we actually basically look at these traditional frameworks. They're using a lot of extensive techniques, right? Tools and techniques that are available. However, with that comes a lot of memory consumption and startup performance. So as the lines of code increase and the complexity of this reflection-based frameworks increases, you end up having a lot of load and cache of reflection data for every single field, method, constructor in your code, right? So you can think of all the runtime overhead, whether it's the proxies or the class loading, class path scanning, and things like that. So all that really adds a lot of overhead. So in terms of how, when we are looking at troubleshooting it within the enterprise, or they have questions from end users and how we have to respond, usually people will be like, oh, if IT, can you turn this off? Can you turn it on again and get that same response time and things like that, right? So you just having to live with that very fat and thick reflection during runtime. So the guidance that we are seeing now in terms of the in terms of the workloads, and a lot of you guys, I'm sure, have already had working with serverless functions like Lambda, and things like that. So as the level of abstraction increases, we move from those server workloads to VMs, virtualization, more to those just functions, right? We're basically seeing that it's moving more towards this application runtime virtualization. So everything is based on your resource, unit scaling, if you will, right? You just pay as you go. And basically all it is just the lifespan of seconds to minutes. But even that, it can add up, right? Even if you go into serverless space and things like that, and you have hundreds of functions, all running in parallel, distributed and so forth, they can add up, right? And there are challenges there. And one of the things that we're going to show is how you can optimize that, and then how can you combine that all in a serverless energy efficient architecture and so forth. But the key thing is we are moving towards the level of abstraction, right, basically increases, and then you're decreasing layers of concern and things like that. So with these modern architectures, what we see is that with Docker containers, you have your unique Java virtual machines, you have observability and all these different tracks, right, that are really built in. So you have a lot of container restart issues that come up if you have multiple JVMs. So for example, we had customers who had like hundreds or even thousands of JVMs that they needed to manage across different clouds. And so each time, there were container restart issues and so forth. There was, coal restart issues, and then resource utilization became an issue. And then effectively it went to cloud billing issues, right? You think about a lot of developer sandbox that need to be maintained even prior to production. So those are challenges, right? So you have your applications and functions, and then your streaming apps, and you could be working with, Kafka, with your events queue and things like that as well. So with all these, we realized that there are different folks transitioning between monolith and microservices architecture. At the same time, you're working with a lot of these gateways and models of that sort. So the serverless experience is quite different, right? In the sense that you are attempting to do, less when it actually is more, right? So you're doing less, which is actually more with that. So the idea is that, you're almost like, surfing in that sense, right? And you've got that no server management, you pay as you go functions, and it can integrate with your, SaaS environment, your platform environment, and so forth. But more importantly, three main things: fast startup, right? And small footprint, small reduced memory footprint, and then your fast time to value, right? So how quickly you can get your first few requests at that optimal throughput, minimal latency, and things like that as you serve your customers, and then they get their experience. So you think about the graph as your idealized approach, of course, is to get the best of all worlds. But in reality, when you start, it could just be a small portion of that graph on the right-hand side. So what I'm basically going to do is just explain to you what GraalVM is first, right? And I'll get to how it works together with functions and that use case. So basically, GraalVM, if you look at it in terms of sort of like a graphical layout, is that you're running any different type of application, whether it's a standalone, OpenJDK, Node.js, or even Oracle database, and you are able to run each of those workloads faster, make them leaner, right? In terms of, we talked about that reduced memory footprint, and then also smarter and more intelligent, right? So in that way, you are able to reduce your latency, right? You also increase your throughput. So you can compile a lot of different types of applications into native binaries and make it more seamless across different types of languages. And you're not locked into a particular cloud environment. So you could run this on, as you will see, on AWS, on Google Cloud, Oracle Cloud Infrastructure, and also Azure. And they actually have support for this available. So when you look at GraalVM and some of the use cases for serverless applications, even before we start thinking about the integration with functions, right? So fast startup and low memory footprint is one of the first things that come out the bat. And that's, as we saw, 2 out of 3, or, are the main things that you look at in serverless architectures. So this helps to make it energy efficient. So the smaller runtime will allow you to fit more functions, per server, per serving, per server, and so forth. So you don't have to sort of, mess around with, your full JVMs and runtime compilers and things like that, right? When they are not needed in your distributed system. Then the other opportunities. So for example, in your serverless functions, you might need isolation, right? So the Docker startup is already quite large, and that also has concerns, typically with Java and how Java resource consumption is actually done. So there's a lot of contention there. And so it's not much better than JVM in that sense. So this way, with the energy efficient architecture of GraalVM, you can keep the tenants in separate heaps and avoid the interference also. Also simplifies many other common use cases, and you can then virtualize access and so forth. Other areas where we're starting to see is like smart caching for database connections and things like that as well. So these are just some of the different types of areas that we actually see, right? Now, visually, you might be thinking, how does this work, right? So if you think of yourself in the middle and you're developing a polyglot of applications and so forth, you could be running it whether it's in a just-in-time mode or ahead-of-time mode. The mode that we've got on the right-hand side is more, tailored towards the functions model, right, if you will. But that's also at the same time cloud native architecture. So when you look at things like Micronaut, which is microservices, a framework that can run with serverless architectures and things like that as well. But also Slim containers with JLink support and things like that as well. So especially if you have smaller operating systems and libraries like Alpine, Muscle, and whatnot. So you have your IoT devices and across platform as well, right? So ahead of time really gives you that kind of that capability. Now let me just maybe shift into a particular use case that essentially I had written about and actually demonstrated, right? So basically, if I look here, right, and you could probably see this architecture. Can you actually see the screen?
Yes,
yeah,
we can.
So you can see it. So you think about a simplified method of making it slightly bigger, of managing your just-in-time and ahead-of-time architecture, and you think about your ahead-of-time is giving you more energy efficiency. What we did was we actually ran a set of IT workloads. So it's actually simulating a search engine with a lot of search queries and things like that, with keeping instances warm and so forth. So you think about like car idling and wasting a lot of resources with fuel and so forth. So did a test, and we ran basically there's a utility. If you look at Intel RAPL, so they have a utility to be able to compare your energy consumption on your architecture. So we actually ran this this architecture with a set sample application that actually was using some Lambda expression, Streams API. It was a combination of Java and some JavaScript. And so we saw that when you compare the just-in-time and ahead-of-time mode, there was a significant reduction, right, in terms of the energy, looking at wattage, joules, and so forth. This is actually the creation of the native image. We actually saw about a 25% reduction in the energy consumption of that same workload that you run. And this was like for like. So you're running on the same machine and things like that. So effectively, AOT helped to, with the cloud native deployment for fast startup, low memory footprint, packaging it up as a static binary. And with that, you were able to, reduce almost 25%. Again, this was some tests run on some machines, but we have also seen, companies like Twitter being able to do something different in that sense, right? So that's one example. And switching back to the presentation, so you can think about these architectures on how this is basically done, right? Now, let me introduce the second concept, which is functions. So we've got, now I'm back in my slides, if you can see the slides. So functions is basically, we've got a open source container native serverless platform. And with
Sorry,
that,
can't see your slides.
You can't see the slides. Okay, let me stop share and reshare. It's just a Zoom thing. Thank you for that. So I think you can see it now, right? Yeah. So what happens with functions is we've got a project. It's out on GitHub. Earlier you saw with GraalVM. So this powers our Oracle functions. This service is delivered on Oracle Cloud Infrastructure, but you could also run it on multiple data centers and your machines and things like that. And the functions are like your containers and so forth, right? So you've got different types of use cases that you can run. We've had integrations for our functions, for even with the flow, running with scalable types of use cases, especially when you have things like fork join chaining and delays that you need integrations. Whether it is travel, or you're looking car bookings, or even security, and you're integrating with the events and so forth. So those are just some high-level use cases. So these are this project is actually available to you, and you can actually download it, run it, and things like that. So GraalVM functions. And now, really, probably the best time to kind of introduce Micronauts. So the framework that helps you run these serverless, or create even the serverless applications, or even microservices, things like that, would be then Micronaut. So it's focused on the modern architecture, right? So this helps to remove all that reflection overhead, right? It's what you call, pre-compute, right? Everything is actually pre-computed in this architecture. So it's a complete application framework, right? So Java annotation processor and so forth. So it's kind of like a supercharged version of Dagger, right, for the server, if you will. So it's a serverless focused Java framework essentially, and with this you can use it to build serverless apps, as you will see shortly, and also things like IoT and so forth. So there's also a large community of message-driven services with Kafka being used here, the producer consumer aspect and all. So at a high level, what it does is it's an annotation processor that hooks into your Java C compiler, right? So, and there's support for other languages like Kotlin, Ruby, and things like that, with dependency injection and so forth. So let me just go into a very simple demo over here. I'm gonna switch over and share this. Just bear with me. The new share. If I can see my VS Code, yes. So you probably can see this now. Yeah, so here is a simple functions example, but essentially how this started is to give you an idea. So this is VS Code. So so how this started is basically from VS Code, I have the capability of having the GraalVM install already available. So it's an extension available. So you can actually have the ability to look at your LLVM, native image, Graal Python, and things like that. And then once I want to create a serverless application, I go to Micronaut as a selection. I select the version, right? And I'm able to select the type of Micronaut serverless function. So if you're here, I select a serverless function, it will then bring me to the type of version of GraalVM that I want to use, like for example, Java 8, Java 11, or Java 16, and things like that, right? So as you know, it's already available there. So all I do is that, and I just create a demo, right? So this could be this meetup demo in that sense, right? And then by default, I put the base package. I select the type of language, so it's Java. And from there, I'm able to even select the different types of project features that I need. So whether it's Micronaut GraphQL and things like that. So essentially, you can add all different types of your capabilities and all this, even in-memory data grid capabilities and things like that. And also on top of it, if you wanted to have some of your JDBC connection capabilities in there, so all that is available, including logging and whatnot. So you include that, you can actually click OK, and then you basically select Gradle or Maven. There's JUnit, Spark, and people usually JUnit, and then it actually creates it and then saves it. So what happens then is you actually get a fully populated serverless application, right? And in that serverless application is everything in Micronaut. Really, you can look at it from the build Gradle file, right? Basically the runtime, your all the implementation platform and things like that, right? So you can actually look at all those things that are available for you. So all the dependency and configuration injection is available. It's pre-computed for you. So you wire apps sort of statically and things like that, right? So this way it gives, together with GraalVM, kind of like closed world static analysis and so forth. So with that, here's the functions test, right? And that's your functions Java in the source, right? So it's basically gonna give you like a hello greeting result in that sense, right? Accordingly, so it'll handle the requests and so forth. The other things that you can see is basically you can just include everything in your connections profile. So here, if I wanted to have automatically resolve my connection to any cloud infrastructure, whether it's Azure, OCI, or Oracle Cloud Infrastructure, I basically do that here and that's it, right? So then when I run it, you will actually see it in the terminal. Okay, now I'm going to run it, and I'm going to run a compile of this, just a Gradle native image. So it creates a native image, goes through the process of this whole queue and so forth. And once I'm done with that, right, you will actually see a file that I'm going to be opening, right? So if I open a, let me go back and new share on the start the share of Chrome tab, which is essentially the Chrome tab. A sec. So can you see my Chrome tab?
No,
You can't see it. Okay.
No.
Let me just go back one time. It should be here. Yeah. So what happens then is that if you see my Chrome tab here, this application that's created, right? Basically your COM dev example, which is functions test. From there, from within VS Code, once that's compiled with Gradle, you actually see a functions test, right? And it runs it, and you're able to see the test, how long it took and things like that as well. So as simple it is from running a complete framework and then launching your functions, capability from within Micronaut, and then you're able to see your functions test. Now, let's try to do some optimization, right, of this function.
Sorry, what is the test framework that's used for Micronaut?
JUnit here. So
okay.
JUnit. Yes, yeah. Thanks. That's a good question. Yeah. So you can actually use your. Sorry about this different screens, because the challenge sometimes here is that showing you different screens of the same version and so forth. But going back to VS Code here, here is so here is so basically what I'm doing is I'm using JUnit for tests, and over here, so JUnit for tests and things like that. So that's where the FN project, as you see, and so that's the functions test and so forth, right? So accordingly, so in terms of the output, so what happens is basically it creates this this build reports test index.html that you just saw, right? Essentially, so that's what happens behind the scenes. And then once I open that report, you can actually see the function invocation and so forth. So from Micronaut, you can actually do that fairly easily. But now let me show you something via the command line on how the functions are actually running much faster when you compare the two different environments. So I'm going to actually dial into our cloud infrastructure, and let me just get my command line here. And it should be here. Yep. Okay. So this is my let me see if I'm connected and so forth. Yeah. So okay. So I'm just gonna basically go in here and log into a cloud environment, right, essentially. And once I log in the cloud environment, I'm just going to go into the, directory where I actually had this set up essentially earlier. And I'm just going to do going to go basically back to the invocation earlier. Earlier in this so forth. So let's do a FN start, and if I can see my keyboard here, here you go. No. Sec. There's some lighting issue. Just give me 1 sec. Yep. Yep, I just can see my keyboard for a minute there. Okay, that was okay, wait. Right, what did I do here? That was %. I should have been there. Okay, maybe I have that already running there. Let me just kill that. already in queue. Okay, let me see. Something running in there. So essentially what happens is, I mean, I have FN already running in here. So what is supposed to happen is essentially once you start your FN, you run an invocation of your cold start function. And when you run it with your Java function versus your GraalVM function, you will see a stark difference, right? So you will see something like with your Java function, you will see a 0.942. And then with your Graal function, you're basically looking at something like a 0.6888, right? So it's about like 50% difference. And that's essentially what happens, which is pretty interesting. And this is something that usually that we see is a big issue when it comes to cold startup issues that happen within the environments, right? So as we look at this, and let me go back to my slide here. So that's what actually some of the supercharged capabilities and all that it comes with, right? So the rest is basically more of your declarative, reactive, non-blocking aspects of your framework, and then everything that you really get from the dependency injection, AOP, and the non-blocking apps capability, right? So this is where when you look at Micronaut and Graal, it makes it easier for you to actually create those native images. There's less work because everything's pre-configured for you, and you can basically just run it from within VS Code. For functions, it makes it a lot easier. So if you want to deploy serverless or gateways, you can just use a Docker-based deployment model as well. So if you don't want to go through, for example, the whole command line setup I have, you can just go through Docker, and actually the whole setup is available for you as well. And then you can replicate it, run it in your test environments and things like that also. In terms of looking at third-party cloud environments, you can also see your that Micronaut automatically detects a lot of your Oracle, AWS, GCP environments and things like that. So if you wanted to run in different clouds for different cloud run functions, let me just give you an example of that over here. So here's an example of how you run when you're running functions in different clouds. So within AWS, as an example, if you can see this, if you wanted to have native image support for AWS SDK for Java, it's available, so you can run it as AOT. And then you can start seeing your startup latency and the first request when you compare the regular JVM versus your native image, right? So, so that will be your differences essentially. And then also your memory requirements and so forth. So there's numerous other tests like that. So this is actually just using a runtime from native image. And then it's invoking some of the features within AWS accordingly, right? So it helps for a lot of these. Here it's using object requests and so forth. There are others that you go in and you can actually have a look at. This is something that was done for a comparison between, I believe, running on Google Cloud Run with Java framework, and then there were some results. And again, showing your cold start issues and so forth. So when you're comparing it with Spring, Micronaut, GraalVM, it actually, significantly goes down even with the memory usage and things like that as well. There are even other ones. So even within the Google Cloud platform, you're able to see within their GitHub repo and so forth, there's actually, GraalVM support for Google Cloud Functions and things like that. So you can actually run it. And you can actually just run the native image, and you can run it with sample links that have been created accordingly and things like that as well. So quite a comprehensive that. There's also work done on the Azure native Spring function. So if you're running things like Spring with Graal on Azure functions earlier, so you can actually compile a Spring Boot application, deploy and run it on Azure functions. And again, it's supported accordingly and things like that as well, right? So that's quite a bit. Just wanted to kind of show you guys on some of the functions for multi-cloud sort of requirements, right? That typically that you see coming out in these days and so forth.
Amitpal, just a quick question on
yes.
the is there some performance test or some kind of data around, like for example, let's say, for example, if I'm using it for AWS, one of the big problems that could come up, especially with the Java runtime, is the cold starts. Like how does the cold start, like the function load up time compares with the default Java runtime that is used for AWS Lambda versus if we use let's say this runtime?
Yes, in fact, there is. So
Okay.
there is that's a pretty interesting one. There was a one where there was, it was actually shown pretty well, and I believe it was something that was shown in this site. And I kind of like this one because it actually was a pretty comprehensive test. It actually shows you how you can actually manage the cold starts in AWS Lambda, and then how you use GraalVM to run Java, in that sense. But
Right.
So it was kind of interesting. There were some performance numbers shared, I believe, at the end, and then you could actually look at some of these and even were leveraged and compared against Go and things like that as well. So this was pretty interesting. So I'll be happy to share more of that. And then I think there was also some from the AWS site itself that they had accordingly that were, how they were able to tackle some of these things in a single code. This is one of them. I believe they actually ran a cold start function, and then they compared it, and the conclusion, basically they were getting like, almost performance improvement of 95% according to, with some of the differences and things like that. So it really depends on the type of workload and also the cloud architecture, but I think it's a very good question that you got. Yeah.
Fine.
Yeah.
All right. And just secondly, just on the same topic, the integration that you are mentioning, it's like we are, is it, for example, like AWS Lambda has this integration of BYOR, like bring your own runtime. Is it like that kind of an integration where we could use this runtime, but in the underlying, we're still working with Lambda only? Or is it like altogether a separate this functions deployment on the cloud services?
Yeah, so that's an interesting question. So we've got this. So can you see the screen I'm sharing here?
No, not at the moment.
Let me just share this. So that's a really good question. So we've got this. If you wanted to say, for example, deploy your serverless Micronaut function to AWS Lambda. So we've got this. So essentially what you would do is the similar thing that I kind of did at the beginning, which is, through VS Code, and, you've got a sample function and so forth. However, when you go in and, you'd open that same report that I did. But when it comes to Lambda, what you would do is, all you do is from within the Lambda part is actually quite straightforward. So you just select your, your runtime. So basically there's a runtime, and then you actually include, GraalVM as part of that. And you do a test, and you create a test event. It'll actually launch, from your native image and using Micronaut. So you will actually be able to invoke that accordingly. So you will have support for that accordingly. And also similarly, if you want to do it with Azure functions and also with Google Cloud Functions, you can do it from within Micronaut through functions accordingly there as well. So
understand. All right. Got it.
There's a more comprehensive one, but that's more tailored to like a particular sort of cloud infrastructure environment. But AWS is fairly used as today these days and things like that. So and so forth. So definitely we've got the one with Oracle Cloud Infrastructure that we can show integration using the Oracle Cloud SDK, and then how native image support is added to SDK and so forth. So we've got those three and so forth. Let me go back to my share screen. The other things basically are, of course, your serverless apps that we talked about earlier, right? So you're writing all your functions for serverless environments. It makes it a lot easier so that you're not locked in to one, and you also have the ability to look at your Netflix, Zipkin, and all the other Jaeger capabilities, so you can have resilience built in. These are some numbers I think you've probably seen already, the before and after effects. So I'm not really going to go in, but at a high level, when we compare or we look at performance characteristics, the just-in-time part is more for peak throughput and latency. but the AOT and native image part is more for startup speed, memory footprint, and packaging size, which you saw earlier. All right. So there's also security capabilities. We talked about the heaps and isolation, but also further, you can add specific types of execution parameters for resource limits and cross-cutting concerns that you have, especially things like buffer overflow and whatever we see these days that are important for static security analysis and so forth, right? There are many more comprehensive demos that, I probably will, breach the time today if I had to show all the demos, but there are some interesting ones where you can run polyglot features and things like that as well, like Node.js together with interactive debugging. We've actually launched in the 2.2 version of GraalVM just released. You probably heard of the unboxing event that happened just yesterday. We have also got a Kafka streaming event going on. We've got others. And here is, basically your serverless integration for VS Code. So essentially together, what you end up getting with all this combination of technologies is that, you get that faster startup, the low memory consumption, and you're able to then go into that next gen of space. You're not limited in any way. You can run it from your VS Code console. IntelliJ even is available. You can compare, even within Micronaut, the before and after, you see almost 5 times difference for startup memory footprints. Not just the limitation there, no more. Even with the data access, you're looking at, hundreds of thousands of ops per second. That could be optimized as well for JDBC, JPA, things like that. So especially, this is just a bit far-reaching, but there are projects like this where you have autonomous stuff, autonomous vehicles. I was just out with my daughter today. I saw a lot of Tesla cars. So there's already a lot of the autonomy cars with a lot of, and you might be interacting with them using functions, with driving methods and things like that. So last thing you want is paying for those cold startups. Imagine that will cost you a lot, right? So that's not something you want to keep paying for, right? So but then you guys, I'm sure, are in different industries, so it's not just about cars and autonomous, but even payment transactions where you need explicit queries, native queries, or trading applications where you just cannot predict the market. For example, where you need profile guided optimization. So you might wonder what happens when I have a lot of different types of reflection classes, and how do I need to include all these things? We have tracing agents that you can run. You can do profile guided optimization. The tracing agent helps to collect the profiles, run it with you, and then you can run your guided optimization, collect the profile, and then you can have more predictability in such market conditions. So in wrapping up, basically, you saw that case of the one where we used that Intel RAPL tool with the before and after. You kind of saw a high-level glimpse of how the Micronaut framework is able to run Oracle functions with GraalVM native image. You can deploy it on premise and into your cloud environment. Essentially, you can supercharge your environments, and you can have your fast startup. And then, you don't have to be consumed into all these energy draining CPU cycles. So one large use case of this is Twitter. So interestingly, Twitter is using it for Scala, and Scala with GraalVM. And they're able to get a lot of these savings, right, for CPU utilization. Another one, besides Twitter, that was more recently announced, and you probably could see it on our website, is Facebook. So Facebook, together with GraalVM, again, using the JIT aspect, right, with no code change, you can basically just use it. Similarly, how Twitter is using it as well. You don't even need to use the AOT aspect, and you start seeing a drop of it. We saw even in some of our proof of values that we did for different industries, we got almost 30–40% difference in terms of CPU or even memory utilization for really complex, heavy applications, right? So it's not to say that you should focus on the monolith and make it better and better. GraalVM has that capability for you, but at the same time, also venture into the AOT aspect, because I'm sure in every industry, you have to push the envelope and make it, like we saw on the first slide, we can't just keep making that thick app more optimized without code change, right? If you really want to leverage the power of serverless and fast startup, we really have to go onto the edge. And that's where the native element is available. So that is why Spring, you look at Quarkus, you look at Micronaut, they're all leveraging GraalVM native image technology to be able to make it, faster, leaner, and then, as part of their framework available and things like that. So other references, we've done tests with Dell, Twitter you heard of. Interestingly, Alibaba is a very good use case. They did the test with AOT, which is our native image. And these guys, they have like hundreds, close to 1,000 JVMs. Probably, I think, if I'm not wrong, I know it's recorded, but I don't want to, probably one of the largest, I think, JVM, clusters in the world, especially with their Black Friday sales that they need to launch. So, they were able to get the startup time decreased from 60 seconds to 3 seconds. So that's a huge, and even GC pause times to under 100 milliseconds, right? So we're not just, if you start, when you look at abstractions, application virtualization, this is going from, down to minutes and seconds, but now in the milliseconds difference. So imagine that level of optimization you're getting. Goldman Sachs was different. I think this is more on they ran their own custom language. So if you want to use Truffle, bring in your own language, by all means, that's available to you as well. So in summary, basically, with Micronaut, Graal functions, you are able to lead the AOT revolution. You can adapt to modern architectures. You can build efficient apps, supercharged frameworks, complete stack, complete framework, and then you can go cloud native, right, across your hybrid setup that you've got. Not just the different clouds, but also your on-premise setup, because I'm sure a lot of you have dev sandboxes and and things like that, and so forth. So that's just tried to cover, I think, maybe a bit too much within that stack, but I thought of giving an overview, and then obviously we can go into more details into the next sessions and so forth. So I'll leave it to questions.